All right, awesome. Well, Nick, thank you so much for taking the time to come to the Big Ideas App Architecture podcast. How are you doing today?
Doing good. How are you doing, David?
I'm doing all right, man. Every time I see you, as I was saying, like this look is like so like tech, So this is awesome.
Thank you.
Yeah. So tell us a little bit about yourself and what your role at Maximus is for the people who are listening.
Sure. I'm a weird oddball. Not so much these days, but back in the '90s, '80s, '90s, when I grew up, I was that kid in high school in the back corner. I graduated 25 years ago, but back '99, late '90s, I was the kid in the back of the classroom cranking on a computer. The only one I had, notebooks had DVD ROMs, and that was the big deal. And the battery lasted 35 minutes, and you're always tethered to a wall. That's how far I've been in tech. My freshman year in college, I was working at Hewlett Packard in the technical computing lab, where we were in charge of virtual multi-tenancy from a on-prem data center perspective. So when I say I've been doing cloud as long as cloud's been around, it was that was private cloud, not public cloud, but that was private cloud. I've been doing that since 2000.
Wow.
I've been dealing with cloud for a very long time. Even before that was, I'm one of the few people that have dropped a 3 meter rack on its face full of servers and oops. But dealing with a lot of this since then, and since working in college, since doing that my freshman year in college, done a lot of enterprise. Kind of generalized architectures for large companies that everybody knows. You drive one of their cars probably, or know somebody who does. And if you've ordered food from some restaurants over the pandemic, you've run through platforms that are back-end microservice-based architectures. That system grew from 15 to 45 services over 18 months with a fully automated prod pipeline with less than 1,000 failures in that 2 year process that we were running it. We processed like 3 million orders, less than 1,000 failures due to platform. So, and this happened right at the beginning of the pandemic. So like, this
Mm.
wasn't that was 2020 we launched, and the world went weird, and being able to enable companies to stay afloat and survive the pandemic was an awesome feeling.
Yeah.
And then coming to Maximus, came over here to help. It was a program for customs immigration service where we basically came in and created a whole new process for them, for the adjudicators, the humans. The hardest process of the immigration process is the humans. So they have to go through, adjudicate individuals, and manually check on forms, and rather than logging into all the various systems, we created them a single pane of glass, grabbed in all the data, and really allowed everybody to know what's going on, and enable them to work much faster and try to help fix that logjam. Because I wanted to stop building. I didn't care about selling widgets. I wanted to do something that actually mattered and helped
Yeah.
impact the world in a good way. Having done this for long enough, you get to the point of like, I'm done building widgets. I want to do something that's impactful. Leave the world a better place. And
Yeah.
that's kind of why I came over here to Maximus. So now I'm a principal cloud architect. I deal primarily in the justice and homeland area. Is a lot
Right.
of the agencies that I work with. We There's a few of us that span a lot of it on our federal side. Maximus does more than just federal business. Basically, for almost 50 years, Maximus has partnered with state, federal, and local governments to provide communities with critical health and human services programs. We basically work with governments to implement programs rapidly, scalable operations, and automated systems from Medicare and Medicaid to welfare to work programs, modernization, and comprehensive solutions that help governments run effectively and achieve their missions and goals. And some cool things that we do. We are the leading administrator of Medicare enrollment brokers for services in the U.S. We answer 7 million calls per month through our
Mm.
contact center contracts that we do. We've performed more than 1.6 million assessments annually worldwide.
Wow.
So that's really what we do. We do a lot of work for helping the citizens of the government, helping the government get the missions done, both at a federal and state and local level.
Wow, that's awesome, dude. I mean, I would love to dig into so much, but that you mentioned, like especially around Maximus, and we're going to obviously talk about that in your work. But you're as a cloud architect, like, how did you fall in love with this? Like, what really happened?
Um, how did I fall in love with cloud? It kind of fell into my lap.
Or,
I mean,
or
uh,
let me say this: like, why did you fall in love with the cloud? Is probably the best question.
okay, why really? When public cloud started coming out and I started understanding that it was what I had done so many
Mm.
years ago, and knowing how, I mean, I was the person that was in charge of rack and stacking. So when somebody wanted a new server, I knew it took 1 to 3 weeks. And that was at HP, at headquarters, getting computers, getting hardware, stacking it, maintaining it, managing it, flashing
Wow.
it, the whole thing. And what that management meant, and the fact that I could push a button and it would spin up in a matter of minutes. I went, this changes everything. Like this is the game changer, not just from a technical perspective, but also from a business perspective. Because I'm
Right.
an oddball in the tech world. I actually have an MBA and a
Mm.
marketing degree because when I went to school, I was in technical computing lab at HP, and I was doing things. I mean, we had motherboards with fans on it testing XP64 for their workstations. Like
Mm.
we were load testing them with just massive fans on it to keep it cool. Because there was no case, there was no cooling. It was just motherboard, proc, RAM,
Right.
GPU, fan. And doing it for real and then sitting in class and being told I'm wrong. And I went,
Mm.
okay, can't do this. So I transitioned more into. I knew I was going to be doing stuff in tech my whole life. I
Right.
knew that it's kind of been ingrained in me. But then getting into more of what got me to love it was understanding where it's come from and knowing those small little tricks that come from the old school
Yeah.
of uh, in a different world. The dot-com boom, I lived through it. I mean,
Mm.
ancillary. I grew up with a single parent, and he had a tech firm. He was an
Mm.
entrepreneur and had a tech company in the '90s. So I grew up. My after school activities were going to the office and hanging out and watching what was happening and marketing discussions. And so I always knew I was going to be in tech. How it actually came about was just I loved cloud because it reduced the barrier to entry.
Right.
It used, capex. I'm going to buy this server that costs $50,000 somehow because I need it for 5 years from now.
Mm.
Okay, cool. I can buy that server, or I can buy a developer. I can rent a space. Like, there's all the stuff associated. And now I can just push a button and it turns on and I have it and I just pay for what I use.
Yeah.
It really changes the game, in my opinion, to kind of commoditizing and helps innovation. And so my probably my big passion is innovation.
Yeah.
What can change? What can be different? And so in doing that, cloud really allows that innovative process and that innovation cycle to happen, because it's all, depending on the cloud provider, as Google says, you can run out of money before they run out of capacity.
Right. Right.
For I think it's Spark, like their high throughput, you they'll give you as much capacity as you can spend, and
Yeah.
you'll run out of money before they run out of capacity. Like,
Oh yeah. I mean, is it Google or like Microsoft have like data centers on the ocean as well now? Uh,
Uh, they've been testing. I mean, great cooling. Water cools 25 times faster than air, so dump it in the ocean where it's really cold. Kind of
exactly.
smart,
It's a pretty smart decision, you know. Yeah.
except if there's a leak. Like,
Yeah.
water and electronics don't mix.
Yeah, that's where you need some multi-region resiliency built into those servers.
Yep. Some
Yeah,
good DR practices and
yeah.
playbooks.
It's funny, I bring this up because I used to work for this company called, I don't know if you know, SunGuard Availability Services. Like, it was an infrastructure company, and all they did was they would have these racks and mainframe systems and Z series, P series, I series just sitting in their data center, waiting to be provided to folks who needed them in case a disaster happened. And that
Yeah.
was a pretty lucrative business till like
Oh yeah.
2007, 2008, 2009. And then I think after the beginning of the cloud, it kind of affected that business because you always had all of this infrastructure available. You could connect to that. You had DR, all these kind of setup. So kind of landscape kind of changed.
Yep.
But I do agree with you. Like the cloud essentially came at a time when everybody was innovating and wanted these new paradigms to like innovate faster and go through different iterations and use what you needed and then come back to it when you need it again, that kind of thing. So I'm
Yep.
glad you fell in love with that. I enjoy the cloud because of those particular reasons as well. But yeah, let's pivot from that and kind of get into one of the things that you mentioned is that when you're an engineer or when you're like somebody who's in tech, we can build a lot of things, but what really gratifies sometimes is building something of value that makes a difference, right? And when you mentioned some of the projects that you worked on, like especially through the COVID, allowing end users and customers to experience no issues, as well as what you're doing right now at Maximus. Tell me a little bit about how the work that you do at Maximus, especially with the federal use cases. What are the challenges that you come across, and how is it different from what a typical, say, a company like Netflix is going to deal with?
Sure. I mean, it's an easy answer, but it's also very hard.
Yeah.
And the best, you probably hear this a lot because you talk to architects, but it depends. Like that is the ultimate architect answer. It depends because everything is different. But I'll just take private versus public sector. So private
Right.
being any company that isn't part of either federal, state, or local government. For the private sector, it's really a choice of what's your risk from a company perspective.
Right.
If you're in a regulated industry, so we'll take Netflix because that's not regulated, super easy. You use them, and their real choice. The only thing they got to worry about is shareholders. You know what's in most in most of the private sector, you're beholden to your shareholders if you're public. If not, you're beholden to your CEO or whoever owns the company. And so your risk tolerance can be much higher than for federal government.
Mm.
So if you're PCI compliant, something happens, there's a data breach, some credit cards get lost. Yes, yes, that's a big deal, but in reality, it's not.
Mm.
You announce, you notify customers that happened. Credit card companies have their checks and balances in place to try to mitigate that risk. But now let's switch over to the public sector, and let's say that it's the IRS. A data breach happens to the IRS. That's a big deal.
Right.
That is that I call those sacred data sets. There's like PII, special PII, HIPAA, that level of data at citizenship, Customs Immigration Services, or Citizenship and Immigration Services, USCIS, or let's say IRS, SEC. These agencies, if data breaches happen there, and let's not forget about DoD. Now we're talking about things that are threats to national security. That if a data breach happens, that's a problem. So the biggest difference is the risk tolerance in public sector is so low
Mm.
because of the data set that's being used, as compared to private sector, which has a little bit more risk tolerance. So that also drives innovation, and innovation in government and in federal work is a lot different because of those requirements of a lot of those pieces. So like I've been talking to a lot of agencies, and a lot, Gen AI is here. It's here to stay. It's not going away. LLMs, Gen AI, it's being incorporated to the foundational level of down to cell phones. And when
Yeah.
that happens, it's here to stay,
Mm.
which is awesome this time because I think it's actually it matters. It helps. I watch my kids be able to interact with the computer without being able to type because they can talk to it.
Yeah.
And the startup companies that I can have third graders writing code by talking to a computer. Like that's straight up sci-fi from 30 years ago. Like
Right.
the Matrix was a mind-blowing thing in the 90s.
Yeah.
We're kind of living there now.
Mm.
Not the fact that we're jacking into our brain stems into our batteries, but like talking to computers and having them talk back in a way that isn't robotic.
Right.
I mean, the chatbots that are out there on call centers, sometimes you don't know they're a bot, but
Oh
they
yeah.
are. I mean, the voice, the voice. So all that stuff is here to say. But where I'm getting to all that and bring it back down is the risk tolerance is low. So Gen AI is here, and I've talked a lot to public sector agencies recently about how can we use it, and we work a lot with the big three hyperscale cloud providers, and how do we and then so how do we work with them to ensure that data doesn't flow out of the model? How do
Mm.
we ensure that model ops or AI model ops is a way that works that can keep that data contained so there isn't data leakage out? I
Right.
mean, would you want your data to be stuck in ChatGPT right now that
Mm.
somebody could prompt engineer themselves into finding out SPII?
Right. Right.
So that's kind of where a lot of the challenges come from is a lot of sitting in that space where you want to do innovation, you want to bring innovation, but you have to move at a very cautious state depending upon the agency.
Right.
So there's agency risk tolerance. There's then, so I deal a lot with Homeland Security. That's 22 agencies compressed into 14 category or 14 different areas that each have different priorities and requirements.
Right.
So though it's just one agency I'm dealing a lot with, it's actually 14 agencies with 22 components that all have to that then have overall like DHS and then each components and the national labs and I mean it's wild the amount of requirements that change, and then an executive order could come out and change everything.
Right. Yeah. I mean, that's important too, right? Like, so how has it changed though? Like, traditionally, these kind of institutions that are governments have preferred to stay on prem or have
Mhm.
their own infrastructure. But I think that's not scalable with, like, I mean, most of these systems are also not Gen AI ready. So a path to the cloud also provisions or modernizes them to like start using some of these capabilities, right? So tell me a little bit about how the landscape has been and how has it changed, in the sense, like, is it more cloud friendly now, or there's like, I know AWS has GovCloud and some of these requirements are coming up, so
Yeah, it depends.
yeah.
But it really, yes. There are some agencies that are very modern, and some agencies that have a very high appetite for wanting to go to cloud.
Right.
But it's that balance. So yes, everything was on prem, really easy. You could secure your data center, secure your in and outs. You could touch the stuff. You had
Right.
air gaps, and I forget which movie it is now. Transformers was a really good example. Cut the hard line. I
Mm.
mean that they have air gaps in place. So if you pull the power, you have little fiber channels. That is a literal air gap. That if something's happening, you air gap it. It's a secured system. You now isolated and have a literal break between you and the internet.
Yeah.
Running on generators, and you are completely broken from the outside world, and you can protect your data.
Yeah.
In cloud, you can't do that. So you have to look at it more because it's software based. You have to figure out how to build those pieces in. And yes, there's GovCloud. The challenge with GovCloud as well is it's not in parity with public cloud.
Mm.
So we'll just talk AWS for a moment. GovCloud is always sitting behind because they have to
Right.
lock a version, have it go through all the security checks and check all the data about where the data flows and how it flows and where it goes, and go through that whole security process. Then it's certified, and then it's able to be used.
Right.
So when Lambda first came out, Lambda is awesome. I love Lambda for that big order process was all Lambda based. 45 services. Fun fact.
45 microservices running on Lambda, right?
Well, and those weren't just Lambda; they were all Lambda process. So for us, the reason why we were so stable, when we do our CI/CD process, we would build the entire infrastructure, test against it, tear it down.
Right.
Because we could. We were running 2 tests, so it cost us very little money to do a full end-to-end test, but we could stand up the entire infrastructure just to do testing in a CI/CD pipeline.
Right.
Like that's some of and that piece also, in my opinion, brings innovation because now I can build new stuff, test it against not a prod-like environment, but literally the prod environment, because whether Lambda runs it here or here, it's the same.
Yeah.
SQS is the same. All these AWS managed services, whether you use A or B, it's the AWS managed service.
Right.
And so you can take that SLA and that guaranteed kind of ability and usability and just use it. So you want to test your system? Automated testing? Yeah, why not? I don't have to, and so I'm not double buying my infrastructure.
Right.
With Lambda, you don't need to have really, besides having it deployed in another region for DR, it's an active environment at all times. Like between Dynamo, if you have Dynamo global tables and Lambda, you're literally an active and can be anywhere on the planet.
Right. Yeah. I think you mean like for a NoSQL kind of workload,
Yep.
essentially. Okay.
Yeah. If you're going to run Dynamo with NoSQL,
Yeah.
because Dynamo has the global tables now and that parity within seconds globally.
Yeah.
But I mean, so Azure has their Cosmos DB. It's
Yep.
Cosmos now. It used to be Dynamo or Document DB. Now it's Cosmos. That
Yeah.
same type of thing. Global
Mm.
parity within seconds. And using that for massive throughput workloads. We did something that I was pushing 1.25 million documents per minute, 24/7, 365 through that for a project that needed to have a data feed for real time transit data.
Right.
And we just used that because of TTL and all the pieces and all the search qualities and everything that we needed.
Yeah.
But we had a collection of 10 million documents in a production workload that was getting hammered, and it kept up and worked.
Yeah. I mean, that's the advantage, right? Yeah. So I think we pivoted to this, but you were talking about how things have transitioned now and GovCloud and how there is preference to the cloud between these agencies.
Yeah. Sorry. So the other thing that GovCloud gives you is the ability to keep those security pieces in place too, because it's certified at a certain. So there's something called FedRAMP and ITIL. Those are kind of the 2 standards. And so anybody out here listening or watching, if you want to work in public sector, make sure it is a process.
Yep.
Don't get me wrong. I mean, it takes time just to get your environment certified to be able to put a workload in. And so that's one piece. But that's something that we did as a company to help us. We actually host workloads for public sector because we
Right.
have that FedRAMP certified space, and then all you have to do is get that workload certified rather than the environment and the workload.
Mm.
So that's another piece that we help a lot of public sector agencies, federal, state, and local, to be able to rapidly put things up and have something in that kind of protected space that they don't have to worry about multi-year process to get it up.
Right. Yeah.
Um,
So this begs a question now, like as a cloud architect, right? Like
mhm.
when this is where the space is going, how has the role of the cloud architect changed? Because you have to kind of take the role of a consultant, obviously, to also educate the people you're working with, to tell them that, okay, how these things still remain, but from a software point of view. So do you feel like you have to wear those hats as well while you're
Yeah.
also architecting a solution for them?
Yeah, this is actually my second time being government. So I went from school. I started working in public sector with Department of Homeland Security Science and Technology Directorate, which was this really cool kind of conglomerate of national labs and agencies to look at it. I got to talk to the person that put the 311 rule in place,
Mm,
the actual director of that division from S&T, and kind of going, why do I have to put all these silly things in a bag? Why does it matter?
mm,
And then he showed me the video of why it mattered, and I went, okay,
mm,
because you cannot get the right collection of the right chemicals in that bag in those different sizes to make
mm.
something that can explode.
Right.
That was the reason why. We'd have to take our shoes off until somebody stuck a whole bunch of explosives into a flip flop.
Mm,
Then we had to take our shoes off. But figuring these things, so that was that group. I worked with them at first, and when I first worked with them, you basically had to be a really smart full stack engineer that knew all the components, knew how to build it. And because solution architects were essentially really smart engineers, and if they were kind of in that done space of, well, I've been an engineer, I've been a senior engineer for way too long, I guess now I'm an architect.
mm.
That was kind of the initial thought back in 2008 to 2015.
Yeah.
10 years later, the architect is now actually an architect.
Mm,
We are the people that have to come in and understand holistically what this means and what's this new piece of tech and how is it going to implement. So it's a hybrid role now between business, consultant, and tech. My other piece that I pull in is security, because that's just the next evolution beyond cloud. Now security is actually top of mind on everything.
right.
Um, so much so that the administration put out the executive order about everything has to be zero trust,
Right.
not knowing what that actually means. Because okay, let's take some COBOL systems and make them zero trust.
Mm. How?
But how? Yeah. But the idea is correct. How you implement it then becomes the challenge, and then you have to make abstractions and all that fun stuff that we all have to do.
Right.
But that's really some of the pieces of the architect now has to understand beyond just how to build it, but what's the cost implications? Because your choice to use tech A versus tech B, I mean, so working with New Relic for the New Relic One platform, we were one of the first test users for serverless on that, not knowing how chatty it got, and the CloudWatch logs bill was 4 times our compute bill
Mm. Wow.
because of how much it wanted to get the telemetry data.
Right. Right.
Because it had never done serverless before. It had just been on, if you have an agent running on a server, it's always pinging out. You don't think about that.
Yep.
But we turned it on, and in a week, we burnt a month worth of cost, or normal cost on CloudWatch. There was like 30 million hits over the month,
Wow.
which is just astronomical for a non-prod system. I mean, we were just doing test in prod. It wasn't like fully out to prod yet, and we were cranking on it like you would on even when we were running full production. We never hit that many a month.
Wild.
But when you're running a couple thousand lambdas and they're all pinging once every minute,
Yep.
that starts collecting up. I mean, that's 60,000 hits an hour.
Yeah. That's
So
why.
that's why the architect has to start thinking about cost. So it's a cost benefit analysis that we have to do a lot. So like my approach that I love to use is I love AWS managed services. They cost more money, yes, but if I need to get there tomorrow, I know it's going to work. I have an SLA. I can build things against it. I can get it to work, build a POC, and be done. Instead of having to go through all the individual steps along the way and build out everything and build it full productionized. But if I need a quick POC, use the managed services, because there is that break even, that inflection point where the cost to build it and manage it is net. You're using it so much, you need to do that.
Yeah.
but but if you build a POC and realize it's happening and it's happy, that's your day. That's your 0 day, not from vulnerability. That's 0 day from how long you have to get it done, and hopefully you can build it in enough time that you hit that break before you hit the break even point.
Oh
So
yeah.
that's where I look at it as, yes, you're paying more money up front to get you where maybe it's a new feature for business needs. Maybe it's that new feature that all of a sudden is a revenue generator that makes your company go from to now a hit.
Right.
Maybe
Right.
it's that new feature in the app, whatever it is, but you can get there tomorrow. I mean, literally, you're now everything also with cloud changed developer roles from just I'm going to write code to now I have to think about how this operates in a cloud environment.
Oh yeah.
Like junior devs now are beyond what would be considered architects 10 years ago, because an architect was a good engineer who kind of understood some cloud stuff because it was just in the infancy.
Yep.
But now your junior devs that have 4 years or less experience, because they've also grown up in cloud and understand it. But now they're thinking of where's my workload and how does it work within that cloud environment, and what, DevOps has been great in developer enablement, and that now as a developer, I need this resource.
Oh
Cool,
yeah.
spin it up, use it, go for it. As an admin on the DevOps side, on the infrastructure side, I don't want to have a ticket to build a server so you can test it.
Yeah.
Just test it. It's going to get torn down at the end of the day. I'm not going to let it burn their 0.
Oh yeah. Yeah, I think it's also good for developers and like just generally for folks who are doing these evals and POCs to kind of understand what the projection looks like. Like, okay, I've added this feature, it's a bunch of Lambda functions and it works really well, but it's going to cost us this much, right? Like it helps you project things out, and it's like good for business, because back in the day you did not know how to kind of plan for scale and plan for peak hours, because a lot of workloads that we know have like hockey sticks, right?
Yep.
Where like they're like flat and then suddenly there's like Elon posted something on Twitter or like somebody, it just went cuckoo, right? Like
Yep.
so I think it gets like all these DevOps and all these key technical paradigms that we're used to now, I think have made things so much more better for folks like us who are trying to develop things.
Yeah.
Pretty interesting.
And a weird thing that nobody thinks about, like I love Lambda for very specific applications. If you need heavy like log levels, because once Lambda is done, it is I consider it as ephemeral hyperscale containers. Like if you just want to think of it as a simplistic, think of it as Kubernetes that's throwing containers away every time you're done running it. So you have to store the data. So usually that's going to go in your queue. So though it might be a lower compute cost, you have to think about the total cost of it, because now you have queue costs, you have logging costs, you have compute costs. So yeah, your compute's really low.
Yeah.
But my bill doesn't change. Why? Because the cost is shifted. But like if you need really heavily logged things for a regulated industry or a regulated agency, maybe it's smarter to stick with more of a containerized application that runs on EC2 or EKS. Or whatever Kubernetes for the cloud platform, because you need that extra that extra logging ability, and you have to run those agents. So, so it gets back to the other consideration of, I don't always get to use the coolest tech, because requirements require me to log everything of every time of every bit, and every bit moves through the system.
Oh yeah.
Okay, so that's not going to be done on Lambda, because no. So yeah, we're going to run it containerized on EC2. Fair. Or ECS. I mean, I prefer ECS because I like the management, because they all push the logs. I have to think, did the log streamer work? But whatever. Like, so it runs in ECS instead of EKS because we don't want to manage a cluster. Or maybe that agency has a large EKS cluster that they manage, and all we get to, and we can then throw workloads on it. So now we don't actually manage the EKS cluster, but we have to manage the workloads on that EKS cluster that's managed by a different team that we don't touch and can't talk to. And so it's when I say it gets really weird and messy, it does, because the requirements for every workload that I work on and every contract is different.
Oh yeah, I'm pretty sure. I mean, they will have these buckets, like these people can only touch these environments. Folks can't do it. They just can push, but they can't pull, or they don't have visibility and things like that. All these guardrails have to be posted. So it completely makes sense, right? One of the questions I wanted to kind of get into from previously what you were mentioning was like COBOL, and the idea that you have these applications that are like extremely complex. They were written like 10-20 years ago by somebody. Those people are retired. And so tell me, 30 years ago. So tell me this, what is easier to migrate nowadays for you? Or when to think about, is it migrating the data or is migrating the application? Or like what have you sensed? in the ecosystem.
Yeah, how to answer this right. Um, so I mean, we all know that in enterprise, there's always that computer under the desk that runs something that is a critical piece of something. Like all
Yes.
of us in this industry know that if we've run infrastructure, at one point it's like, oh, it went down. Why? Oh, we unplugged that computer.
Yeah.
Okay, cool. How do we? Okay, and that person's been gone for 10 years, and now what do we do? So I mean, and I liked how the hyperscale providers. So I'll just pick on AWS again. When they brought out Lambda, they brought it out for Java and Go and PHP. I
What
believe
PHP?
I forget the first
Yeah.
three, but it's three basic languages that are very wide. I'm like, okay, cool. Well, what about those of us that need the other weird stuff? But and then they went, oh yeah, okay, well, fine. Here's one that you build your own runtime. It just costs you more money. Okay, but that was really an interesting way, and that was just leveraging the power of containers in a very interesting way that nobody had thought of. Because it's like, oh, it's just a container. Spin it up, run what you need. Fine, cool. Now you're going to want a really lightweight version of whatever.
Yeah.
But so getting into that realm of I think the easiest thing is always to migrate data.
Right.
Just because data is data, and now if you're going to transform it from SQL to NoSQL, sure there could be some challenges. But if you're migrating from like MySQL to Postgres,
Right.
there are so many that there are now lots of industry standard tools that are from hyperscale providers and very specific companies that can do that. Like migration of data works. I mean, you can even write languages to do it, and I can go on Chat GPT or OpenAI, whichever I want to go with, Bedrock, Copilot, and say, write me a PHP app or a Python app to transform data from MySQL to Postgres.
Yeah.
That's going to go from on-prem to cloud service, and it will give me all the stuff. I fill in the three things. I can be done with that in a day.
Yeah.
Now I need to go validate that data, and so there's more time spent on the validation side, but I can automate the validation. That's fine.
Right. Yeah.
As long as I'm fine to hammer that DB as hard as I need to validate. I can validate every cell within that, every field, every cell. Doesn't matter. All that matters is time and how long you can be without that data. But
Right.
I mean, sure, I'll take a snapshot of the database at this time, migrate it, build up my own infrastructure outside of scope of production business use, and hammer the heck out of it.
Yeah.
Whatever, fine.
Yeah.
I'll tell you, and I can guarantee the data is the same. It's a one-to-one parity at that point.
Right.
So that's why for me, data is easier. Workloads, because when you transform languages, that just gets weird. I mean, because a function that works in Java changes in Go because it's an abstraction, and then you're gonna Python it in between, like it that kind of brings up a point where you get me thinking about lift and shift versus a lift and shift migration. Like
that's where we are going. Yeah.
okay, cool. But like a lift and shift migration, that's great.
Yeah.
But you're building in tech debt.
Right.
And I actually have a quote that I want to pull up because this was something I found. McKinsey did a study on this, and they found that tech debt can cost 20 to 40% of your total spend, of your total value. It says the direct quote: "Tech debt can account for 20 to 40% of the value of a company's entire technology estate."
Wow, that's a
Like
lot.
that's massive. So if we're talking $1 million tech estate, that's a quarter to almost $500,000.
Yeah.
That if you just lift and shift is going to cost you that later.
Wow.
Not to mention, then they start talking into operational efficiencies, because if it's old tech running on new stuff, can you really take advantage of DR if you don't actually have it put in place? So they estimated that 10 to 20% of technology budget for new products is often redirected to address tech debt. So now we're talking about a 20 to 40% cost, another 10 to 20% cost. And then we're really starting, and this is the big one. This is the opportunity cost that you can't really put a number on. Well, they kind of did. But your strategic flexibility. If you have an old system that hasn't been modernized to at least base level of what cloud can offer,
Right.
you can't take advantage of auto scaling.
Right. Right.
Like simplistic things of auto scaling. So you hit that hockey stick, you're done.
Yeah.
You either have to have a massive bare metal server burning at $4,000-$6,000 an hour just for that what if, as compared to spending your couple $100 on your normal workload and auto scale it up as you need.
Right. Yep. No, I agree. Yeah, and those are the patterns that I myself get into conversations with, and I think that's where the key uh, goal to like, should we like lift and shift, or should we lift, tinker, shift? You and I were talking about this when we first met,
Yeah.
and I have this theory that not many people want to do it, but I think that's probably the right thing is migrate the data,
Mhm.
but build a completely new application that can understand this data, but figure out a way to. And the problem with the mainframe systems or these old system is that uh, knowledge management was not done properly. So many times you lost what's connected to what, and so it becomes very difficult for people to kind of build something completely new and from an application level with all the same functionalities, and I think that's where most of the work kind of goes in. So yeah,
Yeah.
that's just my experience. But how about you?
Yeah, exactly. 100%. The difference for my thinking is I take that as a chance to look at it and say what isn't needed.
Mm.
Because when you
Oh, yeah.
migrate, if you're going to lift, tinker, and shift, tinker with it. Cut out unneeded. If you have functionality that's been there just because it's been there, why?
Yeah.
Can we pull it out? Because when you lift and shift it, you're not on that production workload yet, so you have the opportunity. This is one of the only opportunities you're going to get to be able to have it break and not impact business.
Oh yeah.
So push it up there, take some things out, because if you're migrating, you have the source AMI files if you're talking AWS, or the source images. Push it up, take some stuff out, see what happens. Give yourself that. If we're talking a 30 to 50% cost, take that 10% and play.
Yeah.
Let your engineers play. Let your engineers go in and rip stuff out. See if it works. I mean, you can push it to a new database, push it into a new VPC that has nothing to do with what you're doing.
Yep.
But give yourself a tiger team. Take your top engineers that can get things done quickly,
Right.
and let them go rip at it and find it. Every time I walk on a project, I say this is the only time I get to have my first eyes on it. So I dig in deep. I look at security architecture, system architecture, if I have the time, even application logic architecture, data architecture. Where are you doing things? Why? Are you calling a database 16 times instead of calling it once and caching it?
Yeah.
Could we optimize? Where's the optimizations? And that tinker also comes to optimizations,
Oh yeah.
so you could potentially find savings. There was one project I walked on that I looked at one thing and went, this is a 64 node cluster that's only running at 10% average workload.
Oh my god.
Why? Oh, because that's what we have on prem. Okay, so let's cut it. Let's see what the actual usage is. Let's cut it back to 32. See what happens. And during our migration point, I pulled it back to 10 on the cluster because it was for an elastic cluster, and I pulled it back to 10 and just let it go. And people were freaking out, but it had nothing to do with. We didn't impact anything production. It was all in the background. But like, let's see what happens when we start hammering it and seeing what happens in our automated test set suites. And yeah, it spiked to like 95% a few times, and it pinged out at 100 for a little bit. Nothing timed out, but because of the way that it's like, okay, fine. So we don't need 10. Maybe we put 12.
Right.
Or we sit at 10, and when we notice that we hit 8 server load, an 80% load, we know we have the 5 minutes. Spin up 5 more servers. Fine. Spin it up, shard it out. We're good. Let's keep going.
Right. Right.
So or spin up a read replica just to serve the recalls off of where you have your write, just associate write and read replicas.
Oh
so
yeah.
you write
Exactly. Yeah, no, I like that pattern too. Like I feel like it's a good pattern for like high throughput applications where you can do your writes and reads on your main infrastructure and then move non-operational queries to another cluster, and you just read out of there as much as you want and don't bother the application.
Yeah. I mean, that's where the AWS got so right with Aurora. Like
Yeah.
Aurora, it's expensive, but man, that has to be one of the coolest DB, like hyperscale DBs available, because I mean, automatic, like primary failover.
Mm-hmm.
As an infrastructure guy who we get calls at 2:00 in the morning because the database went down, because primary went down. Reads were fine. You could read them all day long. You just couldn't write.
Right.
That just handles it. It's done, and it boots that primary off. The next one comes up as that primary. They add another read at the bottom, and you got 6 versions that are there. Like, so be it. It just makes life easy.
Yeah, no, I have a lot of respect for Aurora. Like, I mean, I work with like AWS. This is one of my partners I work with. But how much do you know about CockroachDB? Because we do. Yeah, like, so the biggest difference, I mean, the reason why I want to bring it up is because you said, like, when it comes to CockroachDB, we don't even have a primary, secondary cluster. We just have one always on cluster you can read and write from. So most of these scenarios that Aurora even kind of gets into, Cockroach never has that, and those are like critical for certain workloads and use cases.
Yeah, yeah. Oh,
That
and that
makes
was one of the things I loved about when I first heard about it. I'm like, wait, you don't have when it was just read write everywhere and everything's there, and it on the surface. And I hope I'm not saying the wrong thing, but it's very blockchainy in its concept, in that the ledger's everywhere, the data's
yeah.
everywhere, and read write is it happens. Um,
Right. Yeah. And I think
the
those are some of the patterns, right? Like where,
Yeah.
I think in Aurora's case, I think I've enjoyed using Aurora, but there were certain workloads where we're like, we cannot have writes going down, right? I mean, this we're talking about like highly, highly, highly mission critical workloads, right? So those kind of cases make sense. But dabbling into the data stuff, right? Like just
Mhm.
because you mentioned Aurora, I mean, I think it's really cool tech. When you think about data migration for these federal use cases, like what kind of mindset do you adopt? Like, so what are some of the best practices that you go through that you can share with the listeners and
Sure.
help them kind of understand, okay, this is how I should be thinking about this problem? So,
My first piece to say is to remove the "it's always been so I can't."
yeah,
Um, in highly regulated industries, when you walk in, it's always been done this way for 25 years, so we can't do it. Okay, well, if you're wanting us to modernize, then let's talk about what we can do, not why we can't.
right,
So that's kind of that first mindset for me as an architect, to walk in and try to make it work better, is just to remove that "I can't." Because when everybody sits in the "I can't," you can't build, you can't invent, you can't talk about what's next. You're just going to talk about what is. And what is what we're trying to fix and trying to
right,
make better.
yeah,
So I will hear, I love hearing about it, but I'm always the person that goes, why? Why is it always done that way? Oh, because it's always been. Oh, so there's no real need? Cool, let's change it. So I like to challenge the kind of normality of "it's always been done that way." So why don't we change it? Because we can't. Why? Now, if there's a law saying we can't do it that way, sure, okay, fine. Then you have to do it that way.
yeah,
But in the most part, a lot of the times I'll walk into it, and why? It's just always been done that way. So
right,
why do we change it? Because that runs into people risk appetite.
right, right,
Because if people's jobs are on the line, another fun thing that I get to do with a lot of public sector is, if there's a big wrong choice, it could be considered misappropriation of funds, which
mm,
means people can go to jail.
mm,
So a lot of people don't have a large risk appetite because it's the potential freedom of choice. So
right,
these are all kind of considerations that you have to take into place of what's the business cost, what's the business need, what's the risk appetite, what's the personal risk appetite for that project or program manager
right,
versus the company versus the agency. So it really is this, like, it's almost like playing three-dimensional chess for a bad or any sort of, thinking of it as quantum physics, or astrophysics of, how do you shoot a rocket out to meet a planet in orbit as we're both moving in different speeds. Like, it's that level of calculations in real time of, okay, cool. So kind of one of my best practices, I poke at the edges, because if nobody's poking at the edges, my job, especially as a consultant, is to challenge and question.
right,
Ultimately, it's my client's projects, my client's money. I will do what they want,
mm,
but it's my job to give them options and to
mm,
ask the questions that nobody else will. Because imagine somebody who's been a career federal employee. They've been working there for 22, 23 years. They're a director of a program. They got 2 years till retirement on a full pension. Do you think they're going to try to do something that might cost them their job?
mm. Well,
Not saying
maybe no,
not
Sorry.
yeah, not saying it's wrong. I mean, that person is considered an expert in the field of what they've done for the last 25 years.
Right,
So for me to come in and ask and go, well, what about these couple things? Also, if it's out of scope, the other big challenge is the scope of the contract that you get assigned or
oh
awarded.
yeah,
Can you change that? Not usually, not easily. So what we're talking about now is for the next 5-year contract, because
right.
essentially you have, and so bringing new innovative technologies is challenging, because it can take 2 to 3 years to get that through the approval process.
Oh yeah, yeah.
So
And
on it,
and
go
by
ahead.
the time you get these approvals done, the technology has gone behind because there's something newer.
Yep.
Yeah,
That's one of the reasons I like working with DHS. They're the newest agency, so they kind of built some of those things into it. DoD is notorious for buying 5-year-old laptops because that was what was on contract. Um, but your contract is you will provide X notebook with X specs. Then that's how, like IBM Toughbooks were out there for forever because
Right,
IBM would build that version of laptop for 20 years.
right, right.
Or Oracle has a database that they'll support for 20 years. Like it's that kind of challenge with a industry that moves at the pace that we do,
Hmm.
where, I mean, Moore's law is stating every 18 months technology is doubling. We're kind of hitting that point where it's slowing down a little bit, but it's still okay, cool. We're talking a 3-year process between when they get an idea and put it out for procurement.
Yeah.
That's still changing at least once, maybe twice, as much
Right.
as 3 times between when you talk about it. So that's another fun kind of piece and challenge with that. Is how do you deal with the innovative challenges of the procurement process
Right.
and getting in the way of innovation. But it should as well, because I don't know if you know about the federal kind of procurement process.
Brief,
Usually
little
first,
bit. Yeah.
so first you get an idea, you then send out an RFI as an agency. The RFA will take 3 to 6 months for industry to go out and respond back to you, and then you have a month or two to read it. So we're talking 3/4 of a year just to get RFI responses, digest it, figure out what that means. So now a year later, you're going to go potentially put out an RFP that's going to take 6 to 9 months to award. So we're talking a 2-year process. Usually it's like a 1 to 3 year life cycle from
Hmm.
a new idea to being able to buy it.
But why is it so slow?
Because the federal government is the largest enterprise on the planet.
Yeah.
I mean, if you get down to it, it is the largest enterprise business on the planet.
Right.
Because there are laws involved and a lot of lawyers. And that's not even if you're going to talk about a protest. If
Hmm.
somebody has a contract and they lose, they protest it, that could stall for another 1 to 2 years beyond that.
Right. Right. Making the
So,
job of the cloud architect way more difficult.
yeah. Well, because now, I got 2 years of a company not trying to update and modernize. They're just trying to maintain, because that contract is good. They're going to follow the letter of the law of the contract for the time that protest happens. And then we got to take it over. So
Yeah.
what we're expecting and understanding what was there is no longer there. What's changed in the last months or years. So then it's kind of like coming in and reassessing everything again because it's been 2 years later.
Right. 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 Yeah.
And
But
and these are potential critical workloads that can't go down because
yeah.
they're mission critical to Homeland Security or DoD.
Right. Yeah. How is the performance expectations though? Like, because back in the day, I mean, I grew up in India, and there's this funny story. Like, you would try to book a train ticket to travel from city A to city B, and the train system was basically owned by the government. And right when you want to book it, the system would crash, and then you basically can't book the ticket for like forever. So what people would do is go and actually try to book the ticket from the counter, and they would end up there at 4 a.m. in the morning for a counter that opens at 8. I've done that actually. My dad and I went and did that. Waited 4 hours because my dad was like, "We won't get the ticket otherwise." I'm like, "Okay, cool." But government systems are always that notorious, especially growing up in India and over here is
Yeah.
like, for not being the most innovative, most like robust systems, and because there's so much bureaucracy, not just that, I mean, laws and things, and people's focus is not on innovation, but to just provide something, right? Like, might be oversimplifying that, but how is it now? Like, at least with federal, like,
So
how is
the
resilience, performance important now?
yeah. I will say that over the past 10 years, things have gotten better as agencies and the federal government. I'll just talk from a federal perspective. They have gotten more of an appetite for cloud to give them the elasticity and availability that they need to
Right.
handle increased workloads. Like, simple case in point, healthcare.gov. That website gets almost no traffic for 9 months of the year,
Mm.
and for 3 months of the year, it gets hammered.
Mm.
Traditional purchasing for a contract like that would purchase max capacity for the 5 years of the contract.
Mm.
So you're spending money on infrastructure sitting there on idle, but you have to buy it because you can't just click a switch and charge more, because you have to know what you're going to spend five. Now this is also some of the challenge, I'll put it.
Right.
Um, you're buying 5 years ahead of your capacity.
a tricky problem.
How often can you be right predicting a 5-year usage trend for something without having the information on it? It's kind of like if you're doing work on your house and you
Right.
have a contractor and you don't like their work, you cut but you got to find a new contractor. You say, I want you to finish the work, but you can't look at my house. You can't take a look at anything. You can't talk to anybody and give me a bid.
Hmm.
So everybody's guessing.
Yeah, yeah.
So that gets to be another challenge in that it's better now. So now with cloud spend, it's more of a cool. We think we're gonna use about this much, and you got to keep it around within it. But it isn't like, okay, cool. I need X server with X specs for 5 years, and you're buying for a 5-year unknown capacity, and maybe we'll get there.
Yeah, yeah.
So that kind of level of change over the last 10 years with more cloud adoption and that the ability is actually saving. I love it because me as a taxpayer means I'm paying less money for more. I'm still paying the same amount of money, sure, but I'm getting more functionality out of it. So like
Yeah, yeah.
healthcare.gov doesn't go to it. When it launched, sure, it went down, but like who could have guessed? I couldn't. I would have accurate. I mean, I would have over provisioned way like 3x what I thought I could have just to make sure it didn't go down. But
Right.
was that in the contract? I don't know. It could have been that contracts are limited to you have this much and make it work.
Yeah.
So it had to go down to go, see, we told you so. We said it was going to be more. Didn't work. I don't know. I wasn't part of that contract or any of those things. But just from a user experience, I look at that and go, that was likely a contracting challenge.
Right, right.
In that, that was a very early cloud adoption piece.
Yeah, but it's also like the problem is you don't really know, like, because I think these kind of initiatives in the federal space is associated with like some law or some innovation that the government introduces, and you don't really know how people are going to really take it, you know.
No.
So, uh,
And, but throw it into an auto scaling group. Like, do I have to over provision? No.
yeah,
But throw it into, if it gets hammered at 100% for 5 minutes, spin up 2x the servers, like just for at least that first few days. But I mean, that's a great thing with cloud. I can automate my pipeline to say update, push to this many servers and put it to a ludicrous number that you don't think you'll ever hit.
yeah,
Like if the mandate is have the system up and available, if you're running 10 servers, turn your max auto scale to 40.
yeah, yeah, yeah.
And as an infrastructure person, would be, if I was managing that infrastructure, I'd be watching it when it turned on for that whole day, and I just have that screen up, watching the CloudWatch dashboard and watching my metrics and seeing what's happening.
Yeah, I mean, true, agreed. I mean, same thing happens. I'm just other examples are like IRS, right? Like January to not even January. I think it blows up in April. I think that's what happens, right? Like, and then right after that, it has to process things. So maybe it's a little bit more up for a couple of months, and then it kind of slows down.
Yep, their heavy times of the year is January through April,
Yeah,
January through May, and then they get another big hit in October.
yeah,
Because October is the deadline for extensions.
yeah,
So that's their big thing. So they're building all year, testing and that's a system and a collection of an astronomical number of systems of smaller systems that talk to each other that do very specific things within it. That I wish I could go into more detail, but like it is an interesting system in the way that it's been built over the
yeah.
years.
We'll, we'll,
And
we'll we'll probably need like 2-3 hours of us like
at
just
least,
chugging
and some
through
extra clearances and
exactly. Yeah,
it's
I know we are even just scratching the surface and not even going in depth. You know, very cool. I mean, I didn't even realize we're like at 50 minutes now. But what's cool about this is like you talk from like what I loved about the way you connect with your experience, Nick, is so real for you, right? Like you worked on these problems, and these problems exist in these ecosystems and agencies, and it's a different world from what private enterprise is kind of trying to solve. Like it's a very funny example. I don't know about you. In 2017, Venmo, was pretty new, and like Super Bowl happened and crashed their database. Like they just couldn't handle the right because everybody started sending money. Like I had pizza, I had chicken wings, and all of this, and then they had to literally get out of their database. I think at the time it was MongoDB, and then I think they kept some of the use case on Mongo and then moved to Cassandra. And it's like, but they can make those changes quickly because the way they have to like talk prove to the shareholders that the money that they've put in is going to get returned and stuff like that. But the federal agencies don't operate like that.
No, it isn't the contract. And
Yeah.
then if that case happened for a program, the federal government come back and go, you didn't perform. You didn't pass the performance to meet the SLA. We want our money back.
Mm.
So there's again, it gets that risk appetite of, do
Right,
you
right.
want to push the boundaries too far?
Fair.
Sometimes it's needed. Like if it's broken, fix it.
Yeah.
And then it depends on the agency and their appetite for the openness, and it depends how long you've been there.
Yeah.
So there are some workloads and some agencies we're working with where they implicitly trust us because of the people that have been there for 20, 30 years.
Right.
And so getting to be that trusted advisor, it really gets to help because it takes twice. It really, I mean,
Yeah.
and this is something to the audience that really, if you want to become a trusted advisor, make the right choice for the customer twice and they will trust you.
Right. Right. Well, yeah, I agree. I agree. I would first of all, I would like to ask you, like, how do you, like, as we close or come to the end, is like, how do you stay up to date with what's up in the market, like with technology, and how do you keep up with it? You know, really, like, and
Yeah.
adopt.
So I'm weird in that I do broad because like if you're a pure technologist and you're focused on writing Java code, that's an easy answer. So it kind of gets into, are you going to specialize or are you going to generalize?
Hmm.
Because I've been working in tech so long and have gone across the different specializations that I've become more generalized just because I transitioned through the different areas
Right.
from writing, building websites in college as a side gig and full stack development from that. And then getting into application architecture, data architecture, now system and security architecture. So for me, it's been kind of a generalized piece. But if you choose the generalized route, you can't have FOMO
Hmm.
because there's too much happening. There
Yeah.
really is. So part of the way that I like to stay up on things is by kind of giving myself time in a week to do it. So I like going to smaller conferences
Hmm.
that aren't, AWS reInvent. It's great. I'm not knocking it. I've been there a few times. I don't want to go again. It's too many people. Like you go to AWS reInvent to meet with clients or to learn about what's the new technology. So if I need to go learn, I'll go spend 2 days and go to the exhibition hall. The last time I went was in 19. So there was the Aria exhibition and the Venetian.
Yeah.
I went to the Aria first and walked that for a whole day just to learn
Hmm.
what was there, and then went to the Venetian
Yeah.
because the Venetian one is the massive, huge
It's
expo
huge.
center.
Yeah.
But like, if you need to go learn info, go walk the booth and go walk the outer edge. The big booth in the middle, the Splunks, the New Relics, like it's all the stuff on the website.
Hmm.
But I want to talk to those small innovative companies, especially when I'm talking private sector, because then I
Right.
can talk to them. Go, oh, you got a cool little tech that's going to work with this thing, and always remember that keep a log. So like I'll keep a log of what I found at the show and the cool stuff, and just keep that in a digital file. And then
Nice.
when I go, there's somebody that asked me a weird question, I just go in there and search for it, and I'll find it.
Right. Right.
So like I have an old Excel file that people have them for passwords. I have them for cool tech I found over the years.
No, I
So
think
that's what I do
yeah.
is that old school rudimentary database. Go in and search it and find what's there. And I'm like, was that company still there, or has it been acquired, or what's happened? So that's how I do it. Is if I have to go to a convention for to support a client or a customer or my company, I try to block out at least a half a day, maybe the last day, and just cruise the floor to see what's new.
Hmm.
I also set up email lists that will be that kind of data flow in of what's happening, what's new,
Yeah.
to get those. And I also look at things outside of tech. So so I don't just get overloaded with just techno babble. I try to give myself 10% time to learn about other stuff,
Hmm.
artistic things. I started down a rabbit hole of learning what it took to do glass blowing, because I saw a show on Netflix that was a competition about glass blowing, and I'm like, that's cool. It's very scientific. It's very rudimentary. They don't have high tech tools, but they make these amazing things that I know I can't do.
Yeah.
So I try to always pick up at least one,
Do
4
a
skills a
skill.
year to
Yeah.
am I going to go do a glass blowing thing? No, but at least I understand the concepts in the tech and what's used to give my brain an extra space of learning new stuff.
Right.
Because if I learn new stuff outside of tech, that gives the tech a chance to go and take that normal stuff and maybe take
Oh yeah.
that widget, instead of it looking at this way, you go, okay, now it's on the like
Oh yeah.
a Rubik's cube, and then you set it on the corner, and now it's that perfect work. It's that perfect thing for your workload that you need.
Yeah.
So that's what I use to keep. I more try to keep my innovative thinking of how do I do things differently than what's out there.
Yeah. No, I think I love that. I think sometimes we can be too tunnel visioned sometimes in our world, and having different experiences, reading books on different philosophies or watching something different allows you to look at something that can be learned from somewhere else and applied in tech, or what you learn sometime in tech you apply in your personal life. And like I get my wife to like follow process at home sometimes because I'm like, why can't you just follow the process, but anyways, but
I
it's
got
it's
Scrum certified, and it made my workflows at home work a lot easier because I'm like, let's run this like a let's run this like a Scrum team. All right,
like a,
we're going to run on sprints. We're going to do with this, and it would just. I mean, it my wife was laughing at me the
the
whole time.
only
She's like,
yellow belt you need is that,
yeah, yeah.
Amazing, Nick. But it's been an absolute pleasure, man, having you here. It's such a fantastic conversation. What I wanted to understand was like, where can people follow you and track some of the awesome stuff that you and your company is doing? Tell us a little bit about that, and we'll punch that in as we post this episode out.
Sure. I'm on LinkedIn because I was in the security space. I'm not massively public social media. That's a whole different discussion and a whole other. We could spend 2 hours talking about that. But I'm on LinkedIn. It's Nik Mayer. You'll see me. I have a big beard. There's young Tony Stark working on an Iron Man head at the top image. Can't miss me. Maximus is on there too, and that's really where I post anything business related because that's you'll find things there.
Wow. Well, that's awesome. Well, I hope to see you at some reinvent. you know? But yeah, it's been an absolute pleasure having you here. Like, it was a great conversation, and hopefully you had a good time talking about your world.
This has been a blast, David. I'm happy to do it anytime you want.